Hello everyone. In this video clip, I'm going to show you some formulas of limit and show you some techniques to calculate the limit of a function to the exact answer, not approximating the limits anymore. Okay, so let's start with the formulas. Say if we have given this limit of f of x, function f of x approaches a is equal to L. And by the way, the definition that we learned before, this notation means when x is getting closer to the value a, then the function f of x is getting closer to the value L. That's all we're saying. And we have another one, another function, say g of x. And the limit of g of x when x also approaches a equal to L, and then how about m? Okay, same idea, just a different function. Now we have a couple formulas that involve the limit. If you have limit of f of x plus g of x, when x approaches a, you want to calculate the limit of the sum of two functions. It's going to be equal to the limit of f of x when x goes to a plus the limit of g of x when x also goes to a. Keep in mind it's going to be the same value of a, okay? And of course it's equal to L plus m because the first limit right here is equal to L, the second limit is equal to m. Okay? And let me save some space right here by writing this way. You can do the same thing for subtraction. This thing going to be subtraction. This is going to be L minus m. Okay? And you do multiplication. It's going to be multiplication. The limit of the product equal to the product of two limits, which is L times m. And of course, the last one is going to be division. F of x divided by g of x is going to be division in here. It's going to be L over m. However, since we are talking about division, we're going to need one condition. M right here needs to be non-zero because we can't divide by 0. It's going to give us undefined. Okay, so at least we have four equation or four formulas to start with. And whenever you guys given two limits, the two limit exists. Okay, limit of f of x go to L, limit of g of x go to m when x approaches a. And what happened when the sum add the sum of two limits? Difference, you subtract the two limits. Multiplication, product, and then division, you have the quotient. All right, more. If you have limit of k times g, g of f is the same thing. G of x, I wrote g already. So g of x, when x approaches a, keep in mind that k right here is a constant. K is a constant. And what can you do with the constant? You can bring the constant outside the limit. So this is equal to k times the limit of g of x when x approaches a. You guys see different from the left and the right hand side of the equation. And on the left, k is inside the limit. Okay? And on the right, k is outside the limit. And you know that the limit here is equal to m, so this is k times m. Okay? And this is a very useful formula. Another one is pretty useful. Whenever you have a constant times the limit, then you can pull the constant outside. Okay. Now let's talk about exponent. Okay. Limit of g of x. X approaches a raised to the n exponent right here. Okay. So in here, exponent n is on the function g, and I claim this is going to be equal to the limit of g of x, and that the whole thing raised to the power n when x goes to a again, and we have one condition for the exponent n right here. N needs to be a positive number. Okay, this is equal to m to the little n. Okay, we have one condition. N got to be a positive number. Okay, I think we almost, oh, one more, last one, which is a pretty trivial one, but some people may not recognize it. Let me erase this. Limit of a constant function, limit of k, x approaches a, and this is just simply equal to k. Okay, this is a function, right? Say f of x equal to k, and then the limit when x goes to a. It's just k. Let me try to explain it using the graph. What is f of x equal to k? It's a constant. It's going to be the horizontal line. This is y equal to k. Okay, so a is right here. X is somewhere right here. X somewhere right there. When x is getting close to a, what happened to f of x? F of x is always equal to k no matter what, right? So this is f of x equal to k all the time. Yes, it is f of x always equal to k value. K is right here. All right. So this, I should bring it at first, but for now it's okay. A limit of a constant function is equal to the constant itself. And those are the formulas that you have for this section. And let's recall something that we wrote last time on 2.1 and 2.2. The limit of f of x equal to L when x approaches a, if and only if we have both limit from the left and from the right, right this way. Limit x go to a from the left, limit x go to a from the right, both f of x equal to L, equal to L. This is just a recall because we talked about this already. Okay? So those are all the formulas that you guys are going to need in this session. Now let me move on. I'm going to show you a couple of examples, and via the examples, we're going to discuss about some techniques that's going to be helpful for you guys to practice. Let me just choose a problem in the book, okay? I'll put it on the board. I see this. Limit x minus 2 over x squared plus 1 when x approaches a 1. This is our function, okay? The question asks you this: what happened to the function when x is getting closer to 1? Okay? In other words, when x is getting closer to 1, what is x minus 2 over x squared plus 1 approaching to? That fraction getting closer to what number when x is getting closer to 1? And what's the idea? So the very first thing, the first priority, the first step that you guys are going to do is try to plug in 1 into the function. If it comes out with a nice number, that will be your limit, because the function exists at that point and close to that point as well. Okay, so plug in x equal to 1. See what you got. 1 minus 2 over 1 squared plus 1. 1 minus 2 is negative 1. 1 squared plus 1 is 2. Oh, that's good. We have a fraction, so the limit is equal to negative 1/2 right away. Okay, and you're done with the problem. The idea, the concept may be complicated a little bit, but with the extra math, all you guys need to practice a couple more, then you guys are going to be good. First step, one more time, is to plug the value into the function and see what happens. So far, so good. Okay, now let's talk about another example. What if you have this? Limit of x minus 2 over x squared minus 4. X approaches 2. We start with the first step again. Plug in 2. What do we have? 2 minus 2 over 2 squared minus 4. This is 0 over, this is 4 minus 4, 0. Oh, it's undefined. All right? Be careful. I'm saying it's undefined. It's not equal to 0. All right? It may not be equal to 0. So if you answer the limit equal to 0, that's not right. We cannot plug in to find the answer. That's all I'm saying. So the next step after plugging in, if it works, awesome. If it doesn't work, you move on to the second step. You try to simplify. Okay? So I'm going to write somewhere in here. Step number 1, plug in. Step number 2, simplify. Okay? And depends on the problem. There are many ways to simplify. In this particular example, we can factor out the denominator. You guys see the x squared minus 4 is really x minus 2, x plus 2. So this is the same thing as the limit of x minus 2 over x minus 2 times x plus 2. And x approaches 2. You see that we have some common factor between the numerator and denominator that we can cancel out. So this is the same thing as limit of 1 over x plus 2. X approaches 2. Now, can we plug in 2 in here? Yes, right? Plug in 2 in here, you got 1 over 2 plus 2, which is a quarter. So really, the limit is equal to 1/4. Okay? 2 basic steps I tried to bring in here. Number 1, plug in value of x. If it works, you're done. If it doesn't work, you try to simplify the function. Okay? In this particular example, the second one right here, we can factor out and we cancel out the common factor to solve. Let's try another one. We'll look at the example. Okay. What about this? Limit of 1 over x minus 1 over 3 all over x minus 3 when x approaches 3. Again, whenever you guys see a limit problem, first thing is you try to plug the x equal to the values approaching right here, 3. I got what? 1 over 3 minus 1 over 3. 1 over 3 minus 1 over 3 over 3 minus 3. So this is 0 over 0, still undefined, okay? And the answer is not equal to 0. Be careful. You don't put the answer equal to 0 whenever you plug in and you have 0 over 0, okay? Or something over 0 is undefined. So you have to calculate it carefully. All right. So we have to simplify the fraction. The denominator is just x minus 3, but the numerator is a difference of 2 fractions. By the way, there was a whole thing right here called the complex fraction. So we're going to simplify this complex fraction. Make the same denominator on the top. So it's going to be times 3 in here, times 3 here, times x here, times x here. I got what? 3 minus x, okay, over 3x. Everything divided by x minus 3, and then limit when x approaches 3. You guys see how I get from here to here? I modify the denominator of the 2 fractions on the numerator. 3x is a common denominator, so 3 minus x over 3x. So I have this. Now divide by fraction means multiply by the reciprocal. So 3 minus x over 3x times 1 over x minus 3. Still have the limit of x go to 3. See the way I write? I carry the limit when x approaches 3 all over. Okay? This top I got 3 minus x. This is x minus 3. I can cancel out with the minus sign because 3 minus x is the opposite of x minus 3. So this is limit of -1 over 3x. When x approaches 3, -1 over 9. Would be the answer. All right. So the second example right here, still follow the 2 steps that I'm showing you, but this time we not try to factor out anymore. We try to simplify the fraction on the numerator. Okay. Try another one. Now here's the main problem. I try to show you a very good technique that's going to help you to solve many exercises, any problems on the finding the limits section. Okay, take a look at this one. square root of 9 plus h minus 3 over 9 plus h minus 3 over h when h approaches 0. First of all, we don't necessarily we're not necessary to use x all the time, right? We could be the variable could be h, could be y, could be z, could be whatever. So in this example, we use h, and h approaches 0. And the first step again is to plug in h equal to 0. What you got? Square root of 9 plus 0 minus 3 over 0, right? Square root of 9 is 3 minus 3 is 0. So 0 over 0 is undefined. So we have to simplify or modify our fraction. And the technique I'm trying to bring to you is to multiply by the conjugate. Think of the conjugate. Okay. Basically, conjugates means what? We change the sign in the middle. Okay. Could be on the numerator, could be a denominator. Think of the conjugate. Okay, so the conjugate of square root of 9 plus h minus 3 is square root of 9 plus h plus 3. You see what we done? We change the sign of that numerator and do the same thing with denominator 9 plus h plus 3. So pretty much in here, I am multiplying the numerator and denominator by the same quantity, which is square root of 9 plus h plus 3 on both numerator and denominator. Means I'm not changing the quantity of the entire fraction at all. So far, so good. And what is so good about multiplying the conjugate? It comes from here. We got, say, something like a squared minus b squared is going to be equal to a minus b times a plus b. Okay, and if we have a minus b times a plus b, you guys see the conjugate in here. A number minus a number plus a number. You multiply those two factors together, you got a squared minus b squared. We apply the difference of square right here to simplify our fraction. Okay, so our problem right here, a minus b times a plus b is really square root of 9 plus h, everything squared, minus 3 squared. See, a squared minus b squared over h times square root of 9 plus h plus 3. This is limit when h approaches 0. And what is so good about the square right here? It helps us to cancel out the radical square root. And this is going to be limit of 9 plus h minus 3. 9 plus h square root square, just 9 plus h minus 3 square. Can I just write 3 square about 9? And over h times square root of 9 plus h and then plus 3. All right, now you see things turn out nicely. What can we do with number 9 on top? Cancel out, because h approaches 0, by the way. So this is limit h over h times square root of 9 plus h plus 3. That h on the top, h on the bottom cancel out, and keep in mind that h still approaching 0. And this is the limit again when h approaches 0. H cancel out, the top is just 1, the bottom is square root of 9 plus h and then plus 3. Now we're okay to plug in h equal to 0 because none of those numerator or denominator will be equal to 0. 1 over square root of 9 plus 3. This is 1 over 6. Square root of 9 and 3, 3 plus 3 is 6. You have the answer. Okay. So the biggest or the main technique I tried to bring to you in this section is conjugate. But to take care of the limit problem in general, we follow 3 steps. Plug in. If it works, awesome. If not, simplify. Well, conjugate is kind of simplifying the function, but I'll put it as a separate step because it's pretty significant. Of course, later on we're going to learn more techniques to solve or to calculate the limit of a function, such as the L'Hopital rule. But for now, the 3 items that I'm trying to bring to this section will be helpful for you guys to practice the exercises. So let me wrap up this section by giving you guys one more example. Okay, let me think of the conjugate, multiplying conjugate one more time, and we we're going to call it the end of the video clip. Look for one more. Okay, found one. Limit u approaches to fraction square root of 4u plus 1 minus 3 over u minus 2 over u minus 2. It's very similar to the previous example, just different numbers and different variables, but the idea is the same. First of all, you try to plug in 2. Let me do a quick plug in 2 in here. I got what? 2 minus 2 in the bottom, right? So something over 0 is undefined. So I cannot have the answer when I plug in u equal to 2. So I try to simplify. Can I factor anything out? I don't think so. But I see the radical right here and then minus a number. Bring back to a very typical method that I'll just introduce to you. I'm going to multiply both numerator and denominator by the conjugate of the numerator. So the conjugate of this is square root of 4u plus 1 and then plus 3. And of course, to keep the fraction the same, whenever I multiply something on the top means numerator, right? I got to multiply the exact same amount to the denominator. 4u plus 1 plus 3. And what is so good about multiply by the conjugate? Again, recalling the formula, a squared minus b squared is equal to a minus b times a plus b. So what we have on the numerator is a minus b times a plus b. Applying the identity. When u approaches 2, we have square root of 4u plus 1 square minus 3 square. And the bottom is minus u minus 2 times square root of 4u plus 1 and then plus 3. And we try to simplify the numerator, see what we got. This one, square root cancels out with a square. I still have to rewrite the limit when u approaches 2. It's going to be 4u plus 1 and then minus 9 all over u minus 2 times square root of 4u plus 1 and then plus 3. Now simplify the fraction. On the numerator, again, I have to rewrite the limit. What? Plus 1 minus 9 is minus 8, so 4u minus 8 over u minus 2 square root of 4u plus 1 plus 3. We haven't seen anything common to cancel out yet, but kind of hidden in there a little. Look at the top, 4u minus 8. The bottom is u minus 2. So if I factor out the 4 on the top, I will have the common factor. So limit again, u approaches 2. The top factor and add the 4. I got u minus 2. See, I got the factor. U minus 2 on the top, and the bottom is u minus 2 times square root of 4u plus 1 and then plus 3. Now I can cancel out the u minus 2. I have still limit u approaches 2. Top is 4 over square root of 4u plus 1 plus 3. Now I'm okay to plug in 2. I got 4 on the top because when I plug the 2 in here, the denominator is non-zero. 4 times 2 is 8 plus 1 is 9. So square root of 4 times 2 plus 1, which is 9, and plus 3. It's 9 square root of 9 is 3 plus 3 is 6, so 4 over 6, which is 2/3. Done. Alright, and this calls the end of section 2.3. Hopefully you guys can get something out of it. Thank you very much for watching and have a good day.